So, a very good afternoon to everyone. I, Akshat Gupta, feel privileged to welcome you all for today's technical session on autonomous emergency braking. Today's webinar on autonomous emergency braking in view of Indian context is a part of Azadi Ka Amrit Mahotsav celebration by Aspire ICAT and organized by PSL Department of ICAT for awareness building on ADAS, that is Advanced Driver Assistance Systems, for industry and students aspiring career building in the field of automotive passive safety. Ministry of Heavy Industries MHI, Government of India has taken initiative to promote innovation and to develop the related ecosystem. To facilitate this initiative, MHI, through organizations under its aegis, is creating technology platforms for various sectors. In line with this recommendation by MHI, ICAT has launched its e-portal named Aspire, that is Automotive Solutions Portal for Industry, Research and Education. The key objective of this initiative is to enhance the technological capability of Indian automotive sector through exchange of knowledge and expertise in order to make them self-reliant and to facilitate the growth of automobile sector and overall socio-economic progress of the country. This technology platform will facilitate the Indian auto industry, including OEMs, Tier 1, Tier 2 and Tier 3 companies, R&D institutions and academia to come together on issues involving technology advancements. The e-portal will act as a one-stop solution. I'm sure those who have already registered on Aspire will agree with me. Those who have not can do so by visiting aspire.icat.in. I now take privilege to welcome our esteemed speaker of the session, Professor Venkatesh Balasubramaniam. He is a professor in the Department of Engineering Design at Indian Institute of Technology, Madras. He works on various problems of disruptive innovations in the product and process development at IIT Madras. Professor Balasubramaniam mentors and advises technology-based startups, SMEs, and automotive industries in strategic management, disruptive and sustaining innovations, new product development, and productivity improvement. He serves as a member of Ergonomics Sectional Committee of the Bureau of Indian Standards and is an Assistant Secretary of the Indian Society of Ergonomics. He was also a part of team that built TAI, that is Tamil Nadu Accident and Emergency Initiative, which was one of the India's comprehensive emergency care programs. He was also the former director of Tamil Nadu Ex-Servicemen's Corporation Limited, TEXCO. We welcome you, sir. I now request you to proceed with your presentation. I request all the participants to write their questions in the chat box. We shall take the questions and answers at the end of the presentation. Over to you, sir.
Okay, thanks for so I was muted. I couldn't unmute from here, so I was muted by the organizer. Okay, so I'm trying to share my screen. So when you get to see the screen, you
Professor, your screen is visible now.
okay, so screen is visible, and I think I am visible too, which Sthiti Kanta had asked. So coming back, uh, so I thank the ICAT Passive Safety Lab for inviting me to give a talk. It's been a while, almost 2 months that we have gone back to classes. So this virtual talking suddenly has its challenges for elderly, I think. But nevertheless, we will just start. So can we have some kind of, who are all there as a crowd? I mean, as the audience here, because I'm not able to see the participation in the list.
Sir, presently more than 150 participants.
So 150 participants are there. Okay, awesome. Then it makes more sense. So what I'll do is I'll talk less, and we'll look at it as a conversation that we can have. We could type out questions and we could have conversations on the question and take it forward. So again, the topic that was shared with me was about the AEB, autonomous emergency braking, and AEB in the Indian context. So in India, traditionally, whenever we are looking at autonomy of things, we say it wouldn't work, not because it's a bad thing, but it's largely because of the complexities of things that exist and how we have to go about. So the next few slides, we will talk about the AEB and some of our work towards in that avenue. Largely, our lab, the slides are kind of skewed. For some reason, some things are invisible in the slide right now, but that's okay. So, uh, we work on broad things. We try to enhance the quality and productivity of people, process, and products. One of the areas that we work significantly is on the transportation safety. So in transportation safety, our interest again has been largely focused on trying to understand the driver, his behavior, his performance, his health, or her behavior, her performance, her health, and that we try to use to get into new product development and other occupant safety. And of course, as Titikanta was talking about, I mean, as the organizer was introducing, we spend a significant amount of time now in the public policy space, and that gives us certain amount of work that we try to do to improve things that we would want to do. I think for some reason the slides are being projected from your platform, and in that process it's taking away some of the things that are written. But anyway, okay, so the organizers, could I just drop off? I'm going to make a PDF of the slide so it becomes easy to project, because the document is not coming out right. I'm going to drop off and come back in. In the meanwhile, if I can have a quick spread in terms of what are the things that excite people, I'll be happy to take a look at it. Yeah, I think I will have to drop off.
Excuse me, sorry for the inconvenience. We just had an internet disconnection. So please allow us another 2 or 3 minutes to again reconnect with the professor. We regret the inconvenience caused. Please bear with us. Thank you. Sir, can you hear us?
Yes, I can hear you.
So you may share your screen for the presentation, sir.
Yeah, are you seeing
Yes.
my screen? Okay.
Yes, sir.
Uh, So I think let me get the audience view. Yeah, I think you. Okay, so this is one reason why autonomy is kind of hated in the country. Uh, I initially thought it was my uh, this thing, net connectivity or anything, although we are sitting on a T3 line, but nevertheless, it works fairly well. So we work on a bunch of different areas. A large part of what we try to do uh, in the entire spectrum of things uh, is to understand what is transportation safety, kind of dumb to say, but that's also something that is essential for all of us to take a look at. And we have something to worry about. Uh, so what where I really thought I should go back and then start. One of the things that we are pretty worried about is about collision and crashes. Uh, we have a large number of deaths, from 130 that is projected by some statistics to 300,000. There is a huge amount of deaths that is there. And significantly the number of injured and crashes again varies from one end to another end. So about roughly we operate with a number, although we project this, we operate with a number that we have about 5 lakh crashes in the country. Now, a large chunk of it has been associated with human error and traffic rule violations that needs to be there. Uh, now, there are other non-wearing of helmets and other basically compliance issues that are there, driving without license and other thing. Now, a question that once this PSL team had brought across and we were thinking about was for these kind of violations which actually leads to a large chunk of accidents, whether this AEB is going to be a solution or AEB is just going to be a technical gizmo for engineers to project about. I mean, contextually, I just wanted to set up the framework that is there. So we again, I mean, it all starts with something that we started about. Whether the data is right or wrong was not clear. It's not clear what's the vehicle engineering side. There is work to be done in infrastructure engineering and trauma care. So basically, the road infra engineering, human engineering, and road engineering, and data collection, and all these three things is the essence of what we need to do. Is the safety framework we built. We started asking these questions to see how we can reduce crashes and other things. So we run a program called the IRAD. Now it's called the EDAR, for collection of crash data and things of that sort. But more importantly, we are also a center of excellence for road safety, where we look at many things, and one of them is the knowledge sharing work that we tend to do, and make sure that we are able to kind of share things that are going to be useful for many, and definitely is the area of interest for us as we go about. Now, we come back to the short thought of what is an AEB. There is a myth that all of us tend to believe, that car, if it can actually detect what is there on the road and do all the activities that are expected to do, and it becomes autonomous by itself without any human intervention, we will then get into a safe space. So there is a significant amount of investments that go into it. There are a lot of impetus and spend that happens to create autonomous vehicle. Now, while we may want to think that there is a human error, the human missed it, the same reasons why the human missed it could also be the reasons why a machine can miss. Okay, so I have to tell you my bias. So I start with that bias, and then in the next 10-15 minutes I will engage with you, and I actually expect to have some conversation types of questions that could be held. So now the autonomous vehicles, as one would want to call, it is a bunch of systems that is going to act without human intervention, right? That is what any autonomous system is. And of course, the emergency is when there is a critical situation that arises, and braking is to brake when a critical situation is triggered. So the whole idea of this autonomous and emergency braking is, if there is a critical situation that comes out, and there is not enough time for a human being to react. Now, what is the time for a human being to react? If there is a signal that is given to a individual. I'm trying to get the pen to write. Let me see if it writes. Okay, so there is a processing unit, and there is a sensing unit, and of course the actuation and sensing usually are nearby. So when there is information that goes out, right, from the sensing unit, and then it gets processed here, and then there is actuation signal that comes out, there is a time lag that happens. Typically, this to and fro time lag is said to be around 600 milliseconds for a healthy adult. Now, 600 milliseconds is quite a bit of a distance, right? Distance as in distance time that you have to look at it. In that time, how much distance that road traversing of the vehicle would have happened, right? Now this processing here is two kinds of processing happens. One is a reflex, one is computation, then decision making. Now if it is a reflex, then it is 600 milliseconds. Start, go, right? If it is some level of computation that you will have to do and arrive at a solution that is reflex, maybe a little bit more you have to add. But then you push into this territory of decision making, then it becomes an extremely difficult task to do for a very simple reason that the human body's decision making uh, part is a challenge that is going to be very difficult to be mitigated because all of us are indecisive. We tend to be fairly indecisive in what we try to do, in what whatever we are good at or bad at, I don't know, but we tend to be very poor in decision making. So the time lag takes significantly longer time, and then the decision taking time, as it increases, it is going to create significant amount of other issues that are there. Unfortunately, I did not know how to do an erase in this tool, so I decided to do the undo to erase it. But anyway, so so what engineers try to think is, now let's not worry about this. Let us actually start looking at removing the human in the system, or in the loop the human is removed. So there is a sensor, the processing and actuation that needs to be there. So there was uh, there was this black hole called the human. So they, we remove it, then it happens within this three, or within the machine itself. You sense, you process it, and you make the actuation. Now, actuation part is the braking part. And sensing is what you sense for the emergency, and you want to build an autonomy in that and take it forward. So as I said, I just want to take from the first principles. We try to take a look at it, and then we go into it. In vehicles, there has been, over a period of time, all of us love to create uh, you know we would want to be absolutely certain about what are the levels in which we create structures. So creating structure is something that we all love to have, and to create the structure, uh, the good old traditional car, which which is fairly plain vanilla, is with no automation, your Model T from Ford, to many of your first cars that you would have, most of you now would have seen better cars. Over a period of time, you start asking what kind of driver assistance would you want to add, right? So where driver is still in control, but you'll then start giving features that can help the driver decide what needs to mean. So there is a processing by the human, so there is a human involvement or intervention that is involved. Now you go a little bit and say that, hey, I will not ask you all the questions, I'll ask you some questions, and then you can answer, and you still work with it. The functions like acceleration, steering, something like a cruise control and things like that, which are partially automated. Then you start bringing in a conditional automation that driver is required to monitor the environment, and the driver must be always available to step up and take over the control that you would want to take. So these all have driver in the loop. Now you want to make a little bit more automation to it. The vehicle is performing most of the driving functions, or almost all of the driving functions. And although the driver can work on its own, I mean, the vehicle can work on its own, the driver can always step in and start controlling the vehicle. of course, when you go full on, it's a driverless car, which is kind of the holy grail that we all would want to, or many would want to approach and then get into it. Now, where does AEB fit into it? Many times people always talk about is what is the acceleration that your vehicle can bring about. But injury and failure does not happen because of acceleration. That happens because of the deceleration, right? So how fast you brake, and whether you brake on your own volition or you're being broken by the extraneous weather. So injury is not due to acceleration. Injury is always due to deceleration. And in the deceleration, if it is not controlled properly and the systems within the vehicle is not working together, then you are in a big soup. Therefore, this entire braking business becomes a okay. Now I've figured out how to erase all drawings. So it becomes much easier, and it becomes a easy thing to work with. Now, the AEB as a system has been, it's not a new concept. No, it has been around for a very, very long time. It's probably, in the 50s, the late 40s and early 50s, people have started looking at it, but most of it has been on the reliability, bulkiness, and other things. So again, you can try to correlate it with the uh, availability of electronics and the improvement in electronics. It's not that it's not because people were not imaginative. It is because the science in or the electronics and computational power had not moved further. But with the advent of 90s and 2000s, miniaturization of radar or LiDARs, laser-based detection, distance detection, and things of that, and reliability of this LiDAR. I mean, today you can measure a laser-based, 10,000 rupees. You have laser guns which actually measure your speed, distance, and closing in speed, meaning it also has Dopplers into it, and you can measure about a vehicle that is going to move. A majority of what the cops tend to shoot at you to find out what your speed and other stuff are. So those are all things that are easy to measure with the advent. So what essentially we wanted to bring across, or at least I wanted to bring across, is people have always been excited about it. People have always tried to, first get this cruise control in place, then have this adaptive cruise control in place, and then the Teslas of the world try to get partial automation in place very fast. So what that leaves us with, what is the technology that we need to have if we would want to get the thing going, and we have a fairly good appreciation of things that needs to be there. So as I was talking about, the sensors is the quintessential problem. So people have always looked at the radar, LiDAR, other infrared and laser based sensors that could be there, and people also use visual information to kind of recompute it, as well as geofencing, so that the decision can be, location intelligence can help the decision to come about. But more importantly, in the actuation, say the devices that has to be pulled out or get operational, tightening of, say, the seat belt, right? So that is one of the first things, because that's the primary restraint, getting the seat belt tightened. The infotainment can also be additional information delivery. Okay, so the tightening of seat belt and other audiovisual warnings that are there is to get the body prepared. So aware, a person aware in an accident usually has less of an injury. All these this is all about the human in the loop, and then of course the vehicle wise, the cruise control that you would want to do, and the brake control systems that you would want to get in play so that you can have a good control of things that are to be done. Now, like all systems, what is the good and bad end of the thing? The good thing always is a vehicle, we can assume that the guy is an idiot and guy who drives it is an idiot, and the vehicle is smart, therefore smart vehicle will not harm the passenger. So we trust a lot on vehicles and the autonomy and the intelligence in the vehicle. So idea here is a vehicle is cruising at about 60 kilometers per hour, hitting a pedestrian has almost near certainty of a death, to a vehicle that has been braking and not hitting the person at 60 at a lesser speed. If a driver has missed the person who could be walking, or the intent of a person who could be walking, right? So the pedestrian crashes, head-on collisions, single vehicle crashes, rear-ending, as well as the fixed objects. That's a single vehicle crash. There's an object standing there; it's not moving anywhere, and we being arrogant, we believe that our vehicle can pretty much get the other thing hit and pushed open, and then you can go forward, but it won't happen that way. So the ability to work with other ADAS systems, is one of the great things. So it is not an individual one, but it's a collection of many things, and the AEB becomes part of a decision-making tool, or within the armory of decision-making. Of course, the demerits is, suddenly there is congestion, traffic congestion, where the distance between vehicle is traded off for ease of moving. So all of you do know that you need to keep 1 car distance, or a 3-minute rule, whatever be rule that people talk about, 1 car distance, 2 car distance for giving braking distance and all. But you are in an extremely tightly packed, rush hour traffic. That 1 car, 2 car distance and all will be given a go by. That's because as a human, you would take a decision that as a social being, I need to push and get closer, take a little bit of risk. But the vehicle is not, if it's going to be taught that emergency braking is to keep this, and that could have a bit of issue that could be there. So people have found out that many of the right turn crashes, owing to various reasons, things have been having a poor performance. So there are other issues where you couple an emergency system with an infotainment. The infotainment hurts. You would pay a lot of money for an infotainment system in a vehicle, but don't really think what is a brake shoe, which is the only thing that is actually finally going to, if you are in a car, it is going to be that friction material that slows the car down and brings it to a halt. That friction material costs 60 rupees, whatever be that number. That friction material, its health are of less importance than the infotainment. We would spend significant amount of money, but AEB will be an equalizer that would come about. Now, The talk is to make it mandatory by 2023 April. Again, I don't hold me on any of it. So if you know a better number, I'll stand corrected on it. AEB in an Indian context, it will be great for a lab level demonstration. Will be a while before we can throw it on the streets. A bigger challenge in an Indian context is our human behavior. It's extremely complex to model it and bring it. So basically what it is the AEB is going to work because you have built human behavior models, and those models or the rules have to be obeyed. If that is not happening, we are going to be in trouble. So the unavailability of the intelligent transport system also adds up to this challenge. Of course, there is climate condition that is unpredictable, and so on and so forth. Anyway, so now over a period of time, our lab, we have been working on the sensing side of the business, a little bit on the processing side, so that we eliminate this thing. So we hold a few patents around how different sensing mechanism could be computed to create a warning system in terms of the driver behavior, performance, and other stuff. One of them is also a product called IntelliSeat. Unfortunately, because I flipped to this PDF, it won't be seen, but you can Google, I mean, you can check it out in the YouTube as IntelliSeat. Harita is now called as Minda, but the thing will still say Harita IntelliSeat. The other thing that we also look at is sensing the human being. So, so not only their presence and other thing, we start sensing their heart rate and things of that, the cardiac activity, and based on that, try to model what needs to be done. And these things are largely from the human element side of the business. So the driver and the driver related stuff, and that into the machine that you would want to put it in. Of course, there is this entire thing about how this human and the machine interact, the method that will be used, as well as the human and the environment interact. That is going to be a bigger challenge than what we look at in the road engineering that needs to be worked on. But nevertheless, understanding this 3M and E makes a big impact in what you would want to do. Now, in the Indian condition, I mean, this is not, and none of this is unique to any place. It is happening in every city, everywhere. You put a median barrier, but a person who is slightly busy and doesn't have the time to wait or cross, or absolutely stupidly in their natural course of place, you have put something and you're asking them to spend a little bit extra energy to do something. Nobody, including me or most of you who are here, would want to do that if we can do this. And as the stakes are increasing, will ability or the willingness to take the chances or the risk that you are able to, appetite for taking risk is there, significantly happen. Of course, in a traffic congestion like this, most of the AEB will go bonkers. It would probably kick in and say, hey guys, this is not in my world. Go back and start working on your way to do. Of course, we have sometimes excellent weather, but sometimes we do also have weather like this. And when we have weather like this, some of the systems which are going to be vision based are going to flunk. I'm sure a lot of you would have seen enough videos of the expressways in which absolute darkness, vehicle were, banging each other, and because they couldn't see the vehicle in front till they hit the vehicle. Of course, there is the wonderlaws of the world, the waterworks that happen. Most cities are prone to having these waterworks and when the waterworks are in play, it does have its own impact. And of course, the landslides and things of that thing which kind of disturbs the whole ecosystem that you would want to be operating with, and try to work with contextually in that one. So we just thought to the end we will take one case and take a look at it. This is the now famous conversation that goes on everywhere, that impact that happened. A vehicle went, hit the bridge on a, they have this 323 laning that was there. Of course, this is moved. I mean, vehicle was great. This adaptive cruise control and all were there on the Surya Setu as you are coming to the bridge. This is not the first car to cross the bridge, right? But this is probably the first car to go and kiss the, the bridge, whatever we would, the masonry work that is there, which is part of the bridge architecture. Now, did the bridge pop up without signages? Those are bigger challenges. Now, could the vehicle have stopped? Yes. These are all the places where AEB could have been a beautiful help, and all these two individuals who were lost. This is just one. A couple of weeks back, a crash we were investigating had about 10 people die in a crash very similar to that. It's a 4-lane suddenly become 2-lane without signage, and people do die, right? So there is cumulative of many things. So even if the signs don't exist, a good braking system could come about and make impact that one would want to have. So if we are able to, as a parting comment, we are able to integrate a large chunk of things, the driver behavior, performance, geospatial information, other things along with in the sensor category. It is not just that AEB kicks in all the time. AEB kicks in when the driver is not performing to his limit. There is some issues that are there. Then we probably will be closer to implementing it. So that's one of the things that which we would want to stop. Thank you for listening to this. If you have questions, you're free to write to me. Please send your emails, and then that's about it. So thank you. I'll open myself for a couple of questions.
Thank you, sir. That was an excellent presentation. We have received some of the questions. We'll take it up a few during this the time we have.
Yeah, please. Thank you.
So we have a question from Mr. Rajesh. How climate conditions create an impact in AEBS?
Again, to simplified answer of it is AEB, essentially you break it down, it involves sensing and it involves actuation. Of course, there is a processing. All three can be messed up with a climate condition. So let's assume that you are, let's take one at a time, sensing. So the sensor that we use, if it's a combination of things, your radar and maybe even A radar may not have any effect because the climate changes, but your LiDAR, another or a camera based another solution, whatever sensing tool that you are using could have an impact. Now, the vehicle dynamics as well as the vehicle, how it would behave once you start applying the brake. Say, for example, an icy road, you punch the brake fast, you're going to start spinning and twirling, right? So those are rules that needs to be coded in. All these things are important one. I'm not saying AEBs would not have coded the rule. All these rules need to be coded, and wherever it is in doubt, it should adaptively come up with some solution. So that is from the actuation side. And of course, processing side, of course, we have various temperatures that we can take things, and when you're taking into temperatures which are not in the kill zone, it can have its own effect on the way things are performing. So that is also an issue that could be coming about. So short answer to use to Mr. Rajesh, will weather conditions have an impact? It is likely to have an impact, but it is not that it is not going to happen. I mean, each AEB, whatever rules that have been encoded into it, and whatever sensing platform, the sensors, how they operate in different weather conditions is going to have the same kind of impact that we have. I know that answered the question. Siddhikanta, am I connected? Hello.
Thank you, sir. For the answering the question, we have another question from Mr. Amit Agarwal. How stop and go feature in automatic cruise control related waiting time is decided?
Okay, so again, I mean, I'll keep the answer short. The simplest one is each of the vehicle create their own system. The waiting time, another thing, obviously is based on certain statistics that people have over a period of time looked at it, but very specific I wouldn't be able to answer. That would be an industry person should be able to tell how each one, if they are willing to share those details, how they are doing this feature and bringing up, because that's part of the IP that they create. Unfortunately, I won't be able to answer that question beyond the point.
Right, sir. We have another question from Mr. Ashish Kumar Agarwal about your views on maintenance of the AEB system in aftermarket.
See, tomorrow if you have a repair in your washing machine, who is going to come and repair your washing machine? So I always use this in the vehicle manufacturers as well as the auto component manufacturer always love to sell you a new product. So the servicing and other thing till warranty is great. Post warranty, this is the market thing. I mean, I'm not sure industry people are here, but more or less the business logic has developed into it. Now, the flip side of it is if we developed enough skill sets of people that are there, we probably can have it. But again, each of these devices and sensors are designed for death. So they are not designed for eternity. So within the warranty period, within the service life period, yeah, there would be some maintenance that is going to be happening. Now, if I understood your question right, in Indian context, we need to build more skilled person. So right there in Haryana, near very close to where they are, ICAT is. They are developing skilled resources in the skill university. Delhi is having its skill university. So you probably have to get more skilled employees. People in the market who can do the maintenance work. But as such, if I'm a vehicle manufacturer or auto component manufacturer, I would rather prefer that you buy a new aftermarket component where I'll make more money than. That is unfortunately the cold logic, but that seems to be the logic by which people operate. Next question, please.
Thank you, sir. I'll now take the last question for today's webinar. I would request participants to mail their questions in case their questions are not answered today. The question is, how do we able to sense a pothole or water wading for AEB? Is there any approach for these scenarios? The question is put up by Mr. Amal TP.
Okay, Mr. Amal, very good question. So AEB, as in the Indian context, why it may not be very successful is it is designed for looking at the road, not looking down. Okay, so the forward looking, not downward looking, is what most of them are designed for. So if the radar is set up to detect all these potholes, then it would be making it for Indian condition better. As far as I know, the systems that are in place, there is a good opportunity for entrepreneur who would want to exploit these things. Assume that our infra will always have potholes, and we will have to address potholes in the braking system. That would be something that someone would want to add one algorithm or have one more sensor that would be looking forward and downward. But more or less, the sensors are designed to look for pedestrians, which definitely have a ground clearance and above a particular thing, as well as obstacles that are above a particular height, so that they are going to have a serious impact on the vehicle. But these are infrastructure peculiarities which could be addressed. Now, pothole is not only for India, but potholes do occur everywhere in the world. So anyone who develops product which is going to be cheap and detect all these things, you will be serving the rest of the world also. But as far as I know, none of them are good at it. Okay.